And we're now recording. All right, we're getting near the end, folks. Today's formal lecture is not going to be that long. I was just going to finish up the last section, and that's it. So 1 through 11, I already did 1. I'll do the rest. Okay. And then I'm going to finish before the break, folks. And then you can ask questions. So remaining calendar. So again, our last regular exam is this Thursday. You submit the homework. You know the rules by now. Submit 16.1 to 16.9. You can start submitting it right after class. That's the ground rules. Okay, and again, you have the entire class period for it. So right when class starts at 6:10, maybe a few minutes before, I'll send through Canvas announcements, the exam, and you have the entire class period to do it. Okay. Then next Tuesday, I'll review for the final exam by going back over the previous exams, and that's how you study for the final exam. All you have to do is review the previous exams, and then the final exam is Thursday, and then we're done. Okay, there's no homework to submit for the final exam. I mean, you're used to always submitting homework before an exam, but not for the final exam. There's no new homework. As far as cheat sheets are concerned, you can have 5 formula sheets. Okay, so if you still have them, hopefully, the cheat sheet you had for exam 1 and exam 2 and 3, 4, and 5, you're still building. Hopefully. Just bring them all in. Okay, so you don't have to reinvent the wheel. If you've got it, then just go with it. If you lost it, you threw it away, you can build it back up again. Okay, if you say to yourself, oh, I wish on test number 3, right, I have put so-and-so, you can do that now. So you can go back and add to it, modify it. Say, I wish I had put down this formula. You can go back and do that for the final. Okay, so most likely scenario. So I normally give about 10 questions. So how about, I'm thinking in terms of maybe 15 questions, 3 from each exam total. So I'll look at the first test and I say, okay, I like that one, that one, that one. And the second test, I'll pick 3. And the third test, I'll pick 3 and so on. Okay, that's what I'm leaning toward. That's not a promise, but that's what I'm leaning toward for the final exam. Okay, so if you just study off the previous exams, that should be fine. And that's what's going to happen on Tuesday's review. Okay, it will not take me that long to do these problems because we're not going to do the harder part of the divergence theorem. Okay, so again, for the divergence theorem, page 1141, here's the last formula. The left side is usually the harder one. If you don't believe me, think of the quiz that you had, think of the one we did in class. The right-hand side is way easier. And you should have gotten something from me about how easy the right side was in the quiz, right? So on the left side, you were doing the front, the back, the left, the right, the top, and the bottom, right? And then I showed you, if you do the divergence of FDV, it comes out real fast, okay? So for the rest of the homework problems, we're just gonna do the right side. We're not gonna do the left side, okay? The right side is much, much easier, which makes the problems fairly straightforward. Okay, so again, it will not take me long to knock off the rest of these problems. I was just gonna pretty much do them all. And then it'll be questions and answers. Okay, and if we're done even before the break, that's fine. But if we go into the break, depending on how it feels, if we can finish a little bit after the normal breaking time, then rather than breaking, we'll just keep going. If it becomes 7, 7:10, 7:15. But if I know it's going to be much longer, then we'll take our usual break. That all depends on you. I will go ahead and say, I know I'm not really supposed to say this as a teacher, but I don't care. I'm trying to make it easier on you guys, right? Okay, if a problem is quote unquote too long, I'm probably not going to ask it. Okay, and I know I'm not really supposed to say that, but that's fine. I mean, you know, you have a limited amount of time. I could very easily give you a problem which takes way too long. So if you ask me to do a problem from the homework that is quote unquote too long, I don't think that's a wise use of our time. And chances are, I would not have you do that kind of a problem anyway. Okay. Now, as you know, for the quiz, I made you do some super long problem, which is okay for a quiz, but probably not something like the last quiz for an exam question. Is that right? Okay, so that's what's happening. Let me check the chat. So final exam is Thursday, that's correct. So just think of Thursdays from here on out, Thursdays are exams. Okay. There won't be stuff that wasn't hit on the exams. That's correct. So to study for the final, just pretty much go off of the previous exams. There was some material that I didn't test. That's always true for any exam. Any exam is only a subset. It's a sampling of what we think you know. So correct, just study the old exams. Okay, that's correct. So just look at the previous exams, and I'll be doing that on Tuesday. Next Tuesday, I'll just go back over each exam and say, look over this, look over this. Okay, so, that's better than saying, go back and study everything, right? Well, it's kind of hard to study everything. So I narrowed it down to just the previous exams. Okay. All right, and yeah, anybody who joined late, let me know. So let's see, Nicholas, I got you later. Elliot, I got you later. And so yeah, okay, let me go ahead and knock off these problems. And then if you have any other questions, that's fine. It will not take me that long. It'll probably take me before our usual break time. Okay, so if you can think of questions you want to ask in preparation for the test, start thinking of them. Okay, if it's quote unquote too long, okay, all right, let's get a concrete example, like the quiz last time. Okay, I probably won't have you do the whole thing unless the whole thing is for some reason real easy. Okay, like for some reason you can tell right away the answer is going to be 0 or something like that. Okay, so but most likely I won't have you do an entire, we'll figure out the front, the back, the left, the right, the top, and the bottom. Okay, again, unless it's super easy. All right. Okay, so last time, the only one I did in its entirety of doing both the left side and the right side was number 1. And I'm not going to do that for any other because the right side in general is going to be the easier one. Right? So let me knock off the rest. So, and just in case, I think I showed it to you, but if not, show it to you again for those of you that don't have the book. Page 1145. So number 3, I'm not going to do the left side, only the right side, the divergence theorem, the third part. Okay. And if I, again, look at the language, use the divergence theorem to calculate double integral of f dot ds. It means do the right-hand side. Okay, so if you see that language on the test, it means it's easier to do the other one. So it says use the divergence theorem to evaluate this. It means do this. Okay, it's way easier. Okay, so there's 5, 7, 9, and 11, and that's it. Okay, so problem number 3. f of x, y, z is z, y, x, that's p, q, and r. And the region E is x squared plus y squared plus z squared less than or equal to 16. That's a sphere, center of the origin, radius 4. So the divergence of f is real easy. By definition, it's the partial of p with respect to x, 0. There isn't any, right? And the partial of q, y with respect to y, the derivative of y with respect to y is 1, plus the partial of z with respect to x, there isn't any. So that's 0. So I have 0 plus 1 plus 0 equals 1. So I'm doing a triple integral of the divergence, 1 dv. But the triple integral of 1 dv means just the volume. So it's simply the volume of this sphere. How do you find the volume of a sphere? 4/3 pi r cubed. So 4/3 pi times 4 cubed, 256 pi over 3. Very nice. Okay, number 5. f of x, y, z is x, y, e to the z, I plus x, y squared z cubed, j minus y, e to the z k. Again, that's p, q, and r. So the divergence of f, by definition, put this on your cheat sheet, partial of p with respect to x, plus partial of q with respect to y, plus the partial of r with respect to z. So derivative with respect to x, y, e to the z. Derivative with respect to y, 2x, y, z cubed. Derivative with respect to z is the same thing, minus y e to the z. Very conveniently, y e to the z cancels out, 2xy z cubed. All right, so the double integral over the region E of f dot ds, don't do that, do the divergence theorem. So I integrate 2xyz cubed. This time I decided to go dx, dy, dz, just for variety, I guess. X goes from 0 to 3, y goes from 0 to 2, z goes from 0 to 1, and that should be fairly straightforward. Although straightforward, triple integrals are never short, so to speak. Okay, so I decided to integrate with respect to x first. By Fubini's theorem, you can change the order. So you can go dz, dy, dx, our favorite, or you can go dy, dz, dx, or whatever. Okay, so integrate with respect to x is x squared, y, z cubed. X go from 0 to 3, dy, dz. Plug in 0, you get 0. Plug in 3, you get 9. Take the 9 out. So now I have integral from 0 to 1, 0 to 2, y, z cubed, dy, dz. That's going to be y squared over 2, z cubed. Y goes from 0 to 2. Plug in 0, you get 0. Plug in 2, you get 2. 9 times 2 is 18. And then I'm integrating z cubed dz. So that's 18, z to the 4th over 4 from 0 to 1. Plug in 0, you get 0. Plug in 1, you have 1/4. Final answer is 9/2. And there we go. Okay, and let me check the chat. Somebody has something in the chat. Okay, somebody just joined. Okay, that's fine. So Michael Decker, I got you. Okay. Anybody joins late, please let me know so I can get you for attendance. Okay, number 7. S is the surface of the solid bounded by the cylinder y squared plus z squared equals 1, and the planes x equals -1 and x equals 2. So that sounds like cylindrical coordinates. Change over to cylindrical coordinates. Okay, although it isn't, z stays the same, x stays the same, and y and z become r cosine theta and r sine theta for number 7. Okay, so it's a little bit tricky. So f of x, y, z is 3xy squared, x e to the z, z cubed. The surface is y squared plus z squared equals 1. Okay, if I only look at this, suppose there were no x. If I look only in the yz plane, right? The yz plane, this is a unit circle. Now let x go from -1 to 2. So you have a circle and it goes like so. So you get a cylinder, right? Which means cylindrical coordinates. All right, so the divergence of f is p sub x plus q sub y plus r sub z. So derivative with respect to x, 3y squared. Derivative with respect to y, there is no y, so 0. Derivative with respect to z, 3z squared. Factor out the 3. 3 times y squared plus z squared. So that's what I'm integrating. Okay. And I switch over to y equals r cosine theta, z equals r sine theta. Okay. Yes, we're used to x equals r cosine theta, y equals r sine theta, but in the yz plane, right? The yz plane, our convention was to make it look like this. So y is playing the role of x, and z is playing the role of y. So that means y is r cosine theta, z is r sine theta. Okay, so the triple integral, or formally they asked for the double integral of s of f dot ds, but it's a lot easier to do the triple integral over the region E of the divergence of f. So I'm integrating 3 times y squared plus z squared, 3 y squared plus z squared dv, and then I switch to cylindrical coordinates. Okay. So in the yz plane, y squared plus z squared is r squared. You're probably used to x squared plus y squared equals r squared. But in the yz plane, again, y is playing the role of x, z is playing the role of y. So y squared plus z squared is r squared. And then you might recall for cylindrical coordinates, it's r. We're used to saying dr, d theta, dz, but in this case, X is the one that stays the same. So it's dx, dr, d theta. So r squared is y squared plus z squared times r dx, dr, d theta. Okay, x goes from -1 to 2. We're going all the way around a circle. So r goes from 0 to 1. Theta goes from 0 to 2 pi. Okay, so that's going to be r cubed, right? This expression does not involve theta. And it also doesn't involve x. Okay, so I'll take them one at a time. If I integrate dx, there is no x, so I just multiply by the length of the interval. X is treated as constant. So how far is it from -1 to 2? 3. So 3 times 3, it'll go from 0 to 2 pi. This also does not depend on theta, so take out the 2 pi. So outside I have 9 times 2 pi. And then I integral r cubed. So 9 times 2 pi, that's for theta. R cubed over 4 from 0 to 1. Plug in 0, you get 0. Plug in 1. 9 times 2 pi divided by 4. 9 pi over 2. Final answer. Okay. All right, so that's 7. Show you all of that there. Okay, 9. Bold f of x, y, z is x e to the y plus blah, blah, blah. S is an ellipsoid. Okay, so how do I do an ellipsoid? Turns out you don't have to worry about that for this particular problem, as you shall see quickly. So bode f. So again, when the book does bode, I do the vector, as you should know, right? F of x, y, z, x e to the y I plus z minus e to the y j minus x, y, k, p, q, r. So the divergence of f is the partial of p with respect to x plus the partial of q with respect to y plus the partial of r with respect to z. Okay, so what's the derivative with respect to x? E to the y. What's the derivative with respect to y? Minus e to the y. What's the derivative with respect to z? There is no z. 0. Divergence is 0. So if the triple integral of 0, so it doesn't matter if it's an ellipsoid or circle, square, sphere, cube, whatever, the answer is automatically 0. Do you like that? So that was very easy. Okay. I'm done after 11, folks. So capital or both f of x, y, z is blah, blah, blah. They got I, j, and k. I'll write them with angle braces. And they give you some surface there. So we have to figure that out. Right, so I'm finished in a few minutes, in which case I'll let you ask questions. And if you don't have any questions, we're done. Okay, so again, Thursday, last regular exam. Next Tuesday, review for the final, and next Thursday is the final. So think of it, every Thursday from here on out is a test. Okay, test 5 and then final exam, and then we're finished. All right, so the divergence, so differentiate with respect to x, 6x squared. Differentiate with respect to y, 3y squared. Differentiate with respect to z, 3y squared. So I have 6x squared plus 6y squared. Okay, now they said z equals 1 minus x squared minus y squared. Okay, which means if I plug in 0, 0, z is 1. So that's the point way up here. Now, how about in the xy plane? Z equals 0, that's x squared plus y squared equals 1. So I have this picture right there. Okay, it's bounded by the paraboloid and the xy plane, so I'm only right here. I'm only showing you the first octant view, actually. Imagine you're going all the way around. Okay, so I have the triple integral over the region E of 6 times x squared plus y squared dv. We know x squared plus y squared is r squared. Okay, so switch over to cylindrical coordinates again. So 6r squared okay, 1 minus r squared. Okay, this is 6r squared, 1 minus r squared, r dr d theta. Okay, and I have to think about where I got the 1 minus r squared right here. Yeah. 1 minus quantity x squared minus y squared, that's 1 minus r squared. So this part right here is like z. Maybe I should put that down here. R dr d theta. Okay, r is going from 0 to 1, theta is going from 0 to 2 pi. Whoops. Okay, so I'm basically thinking of 6r squared dv. So when you integrate dv, you're finding volume under a surface. The surface is z, 1 minus r squared. Okay. So that becomes 6r cubed times 1 minus r squared, 1 minus x squared, parentheses x squared plus y squared. Okay, so this thing doesn't depend on theta, so take out the 2 theta. Take out the 6, r cubed minus r to the 5th. Okay, 6 times 2 pi, 12 pi. Then the rest is easy. R to the 4th over 4 minus r to the 6th over 6 from 0 to 1. Plug in 1, 1/4 minus 1/5. 1/6, plug in 0, you get 0. Okay, that's 3 pi minus 2 pi. So the final answer is pi. Okay, and let me show you, let me do the focus thing, but otherwise I'm finished, folks. Okay, so if you want to ask me anything, either unmute yourself now or put it in the chat. Okay, again, if the question is too long, I may not be willing to do it. And frankly, you're probably not going to get it because I know you have 2 hours and 15 minutes, which seems like a long time, but you already know, and I already know, that some problems can get really, really long if you wanted to get long. Okay, I'd pick another page to do problem 7. I already showed that to you. But after I'm finished with this, we are done with Calc 3, folks. So give that to you there and there. Okay, so I'm finished. Okay, I do see something in the chat, so let me go to that now and sort of take notes on what we have here. Okay, 16.635. Okay, and while I'm at it, yeah, I can only look back at the chat occasionally. So does anybody else have a question in the meantime? So I don't have to switch back and forth. If not, I'll just go ahead and start that one. But if you still want to type something, you may. Okay. Why don't I get the book and start looking at that one? $16.635. Okay. $16.635. Okay. I'm actually wondering if I already did it, because if I already did it, I'll just show you that rather than start over. But if not, and it looks like I did not do it. Okay, so let's see what it says. R of UV, U cosine V, U cosine V, u sine v, v. U equals 1, v equals pi over 3. Okay, so we do have to translate this to an ordered triple. The closest one to this problem is like 33. Just try to follow the template of 33, as it were. Okay, so first I need the point. So plug in 1 pi over 3, cosine of pi over the cosine of 60, same as sine of 30, 1/2. U sine of v, 1 times the sine of pi over 3 is radical 3 over 2. And then v, which is just pi over 3. Okay, so I need r sub u, derivative with respect to u, cosine v, sine v, 0. R sub v, derivative with respect to v, negative u sine v, u cosine v, 1. I need their cross product. So if you want to know what I'm doing, you can pretty much just follow along, same template as 33, just kind of look at that. So, whoops. RU cross RV, I, J, K, cosine V, sine V, 0, negative U sine V, U cosine V, 1. So it's I times sine of V minus cosine V minus nothing. And then U cosine squared V minus a minus, so plus U sine squared V. And we know that's equal to U. So we have sine V, negative cosine V, U. Now I plug in. So I plug in U equals 1, V equals pi over 3. So sine of pi over 3, sine of 60 degrees, radical 3 over 2. Negative cosine of 60 degrees is negative 1/2. And U is 1. Right, so that can be considered my normal vector. It's not going to get any better. I suppose you can make it better if I multiply by 2. Okay, so multiply by 2. Radical 3, negative 1, 2. So that is a normal vector. So I have radical 3x minus y plus 2z equals k. To find k, I plug in the point, which was, where'd it go? 1/2 radical 3 over 2 pi over 3. Plug in 1/2 radical 3 over 2 pi over 3. Okay, so radical 3 times 1/2 minus radical 3 over 2 plus 2 pi over 3 equals k. These guys cancel out. So k is 2 pi over 3. So final answer, radical 3x minus y plus 2z equals 2 pi over 3. Okay, so that pretty much should be it for that one. Okay, let's see.
Professor, real quick on that last one,
27. Yeah, somebody had a question?
Yeah, what the answer to that last one, what is that exactly representing? That equation?
That's the equation of the tangent plane to the surface. So the surface has some shape, is defined parametrically like so. You at a certain point. Okay, so you have some curved object. You're given a single point. There's a tangent plane. This is the equation of that tangent plane.
Okay. All right. Thanks.
All right. Let's see. I think, sorry, it's hard for me to do the work and find the numbers while I'm at it. 16.727. The next hard thing is find all the pages that I want. $16.727. Oh yeah. Okay. Yeah, it's a nice one. It came out long if you did it. Okay. So do I want to spend time on it? Yeah, probably not. If you did it, great. I'll just say some things about it. It's a nice problem. So yeah, I've given it away. I won't be asking you that entire problem. But y equals x squared plus z squared. And then x squared plus z squared less than or equal to 1, y equals 1. Y equals x squared plus z squared. X squared plus z squared equals 1 at y equals 1. So if y equals 1, in the xz plane, you have the unit circle, and you have this paraboloid here. Okay, so if you're talking about the flux across the surface, okay, this would be considered outward, this would be considered outward, and so on. Okay, so yeah, in the interest of time and where we're at, I'll probably say abandon it, and I won't have you do that one because it's too long. So sorry about that. See, 16.421. And I mean, you guys have had teachers before. You probably play the game where I mention it. Hey, this problem is so long, he's probably not going to give it. So I'm admitting it right up front. Okay, if a problem is too long, I won't give it to you. Right. So let's see. 16.421. Yeah, I didn't assign it, so I'd rather not discuss it. Okay. Seems like somebody said X, Y. Okay. So yeah, since it's not an assigned problem, I want to stick to that for now. So I'd rather not do that one. Okay, and let me see what else there is. I'm here. Okay. So again, if you came late, please put your name in the chat so I can get
I
that.
did have a question about 16.8, number 3.
Okay, hang on. I'm sorry, I can't read and listen at the same time.
Okay.
So I'll get you in just a second. Okay, yeah, sorry. What was that again, please?
I just wanted to have some help finding R of t.
R of t, okay, which one?
16.8, number 3.
16.8, number 3. Okay. Bold f of x, y, z. Z e to the y. X cosine y. XZ sine y. Probably notice I did the lazy way, not put the I, J, and K. Okay, so the main thing is what's the R, right? So S is the hemisphere, x squared plus y squared plus z squared equals 16, oriented in the direction of the positive y axis. So we have x squared plus y squared plus z squared equals 16. That's a sphere centered at the origin with a radius of 4. Actually, I should put rho equals 4. Y is greater than or equal to 0. And oriented in direction of the positive y-axis. Okay, so I think it's like this, right? So direction of the positive y-axis is inward. So inward would be negative. All right, so let's see. For this one, spherical coordinates, the problem with this is we're not used to the orientation of this. So I'm thinking the best way to show you how to do this. So we're used to x equals rho sine phi cosine theta, y equals rho sine phi sine theta, and z equals rho cosine phi. Okay. The problem with this, and this would be very easy if I had a situation like so, right? Where they said z is greater than or equal to 0, then it's the way that I want it to be. So I have two choices. The choices are to change the problem. It seems like I'm cheating, but if you stop and think about it, it'll be the same. I mean, everything here is symmetric, right? X squared plus y squared plus z squared equals 16. If they said z is greater than or equal to 0, can you kind of see that it'd be the same thing? Right? You're just renaming x, y, and z. So one way to do it is to just change the problem into, say, change to z greater than or equal to 0, and then we're comfortable with that. It should not be a different answer, right? X, y, and z all completely symmetric. And the reason why I like this is because we're used to it by these rules here. So since rho is 4, so parametric, I have x is 4 sine phi cosine theta, y is 4 sine phi sine theta, and z is 4 cosine phi. And then from this picture, theta goes from 0 to 2 pi. Phi goes from 0 to pi over 2. That I think is the easiest. The other option is much harder, and I'm not even sure if I want to show it to you because I think I might just mess you guys up. Okay, so if you understood this, that should be good enough. Okay, so you need two parameters. The parameters are theta and phi. Rho is not a parameter. Rho is stuck at 4. So the two variables are theta and phi. Theta goes from 0 to 2 pi. Phi goes from 0 to pi over 2. So again, we're semi-cheating, but it said y is greater than or equal to 0. Okay, but if you look at this, if I said x is greater than or equal to 0, it'd be the same thing. Everything's symmetric. y is greater than 0, or if it said z is greater than 0, it's the same hemisphere. I mean, you're just kind of turning the picture around. It should be the same answer. That's what I think you should do in this case. It's much harder if you insist on keeping it like this. Then you have to kind of change the definitions of theta and phi. Okay, so whereas before phi was defined starting at the positive z-axis, here by analogy, you'd have to start with phi defined going in the positive y-axis and then coming down like so. Okay, you would essentially get the same thing, but I think it's probably easier to just leave it like so. So that's how I'm going to do this rather than try to open up a can of worms and foul you guys all up, and just keep this, which is what you're comfortable with, I think. All right. Okay, and Sichi, I got you here. So, all right, I think I've cleared the chat. Let me go back and check. But anybody else with a question, please? Let's see, Lewis, I got you. Anybody for attendance, I'll get you eventually there. Okay, 16.315. Okay, so F is equal to YZI plus XZJ XY plus 2Z K. And we're going 1, 0, -2, going to 4, 6, 3. Okay, and let me do it this way. Okay, it's almost our normal time to break. I need to judge whether or not to break or to just keep going and get it over with. So let me ask this, if I could, please. If you plan to ask any question at all, can you ask it now or put it in the chat, please? Okay, so do it within the next few seconds. And then I'll determine, okay, there are too many questions. We'll break as usual and go on. But if there aren't that many questions, then say, okay, forget the break. Let's just keep going and get it over with. Okay, so maybe I'll give you 10 or 15 seconds to do that while I get started in this problem. Seize the line segment. So let me at least keep going for this one. All right, so find an anti-gradient. So that means this is Fx, Fy, Fz. Okay, so again, if you plan to ask any more questions, please put it in the chat now so I can determine go or no go. So Fx is Yz. Integrate with respect to x. F of x, y, z is x, y, z plus g of y, z. And then I differentiate with respect to y. So derivative with respect to y is xz plus gy. And then I compare it with the fy here. It has to equal xz. So if xz plus g sub y equals xz, that means g of y is 0. But it still might be a function of z. Okay, so that means f of x, y, z now becomes x, y, z plus h of z. And differentiate with respect to z. Fz is xy plus h prime of z. And then I compare that with this, xy plus 2z. Okay, so xy plus h prime of z equals xy plus 2z. So that means h prime of z has to be 2z. So integrate. So h of z equals z squared plus k. So now I have f of x, y, z. Put it all together. It's x, y, z plus z squared plus k. Now evaluate the work done to integral of f dot dr. Fundamental theorem of calculus for line integrals says all you do is plug in the ending point, plug in the beginning point, and subtract. Okay. So use f of x, y, z has a k of 0. So x, y, z plus z squared. Okay, so let's see, pinning myself into a corner here. Let me see if I can sneak it in here. So the integral along C of f dot dr. Show that to you quickly. So for conservative vector fields, page 1087, f of r of b minus f of r of a, which means plug in the ending point, plug in the beginning point, and subtract, which is just a higher dimensional version of what you did in Calc 1 and Calc 2, right? So I want f of 463 minus f of 1, 0, negative 2. And not sure how nice this comes out to be. So f of 463, 4 times 6 times 3 is 72. Plus z squared is 9. F of 102, 1 times 0 times 2 is 0. Plus z squared, negative 2 squared is 4. Okay, so that's what, 81 minus 4, 77. And that's my final answer for that. Okay, and I don't see anything else in the chat, so I'm assuming that's about it. Let me do my focus job here. Okay, so if there's no other questions, I'll give you a chance to ask while I do this focusing thing. Okay, so that's going to be it otherwise. So again, next time, no question and answer. We'll go straight to the test as usual. So a few minutes before class, I'll send it to you via Canvas announcements. And you can start submitting the homework as soon as we're done here. But again, if not, you have until half an hour after the exam to submit the homework. Next Tuesday, we will review for the final, and next Thursday is the final. And then that'll be it. Move that over there. And yes, you may play the game. If a problem was quote unquote too long, I probably won't ask it. Okay, or I would be willing to ask you maybe a small portion of it. Okay, or get one of those boxes, right? Say, okay, just analyze the front surface or the back surface or the top, but not all 6 of them, for instance. Okay, I think I've caught up. Let me go back over the chat in case I miss anything. Okay, but otherwise we're done, folks. We can call it a night, and then we'll see you next time. Okay, well, if I miss anything in the chat, I can look at it more carefully later and send you an email if I get to that. Okay, I think that's it, folks. So anything else? All right, I see nothing or hear nothing. All right, so we're done, folks. Have a good night. So see you next time for the test, all right? Okay,
Thanks.
bye, everybody. Good night.
Thank you.
Right.
Yeah.
Thank you.